question on electric potential. So first we'll see what is electric potential is. So it is the amount of work done in moving a unit positive charge from infinity to a specific point in electric field. So it is the amount of work done in moving a charge from a reference point to a specific point. So we consider a positive charge Q. Okay, when it comes to the electric field, this positive charge will experience as a force. The electric potential at point P due to this positive charge at a distance r is given by V is equal to kq by r, where k is the constant, 9 into 10 to the power of 9, and q is the charge and r is the distance between this point and the charge, and unit for electric potential is volt. Okay, first problem. The electric potential at a point x, which is 0.6 meter away from a 80 microcoulomb charges. So consider a charge of, as given the question, 18 microcoulomb. So Q is equal to 18 microcoulomb. Okay, you have to find the electric potential at a point x. At a point at x, you have to find the electric potential at a distance of 0.6. So R is equal to 0.6 meter. So we know V is equal to KQ by R. Okay, so K is equal to 9 into 10 to the power of 9 into Q is 18 into microcoulomb. So you have to put 18 into 10 to the power of minus 6 divided by R is 0.6. Okay, so after substituting the values, we get V is equal to 270 into 10 to the power of 3 volt. So substitute the values in this electric potential formula, we'll get this answer. So answer is A. Okay, so this is your answer. Next question is, potential at a point due to a given point charge is directly proportional to. So potential at a point due to a point charge is directly proportional to. So we know the formula, V is equal to, potential formula V, electric potential V is equal to K in Q divided by R, right? So what is the relation between the electric potential and the distance R? They are inversely proportional. So V is inversely proportional to R. Okay, so the distance is very far away from the positive charge, then the potential will be, they are inversely proportional. Okay, the distance increases, potential will get what? Decreases. So answer is option B. Next is X, Y, Z are the points in uniform electric field. At point X, electric potential is maximum or minimum or same as Z or same as Y. So you have to find out what is the potential of X. Okay, so we know that the electric field lines will start from high potential region to low potential region. Okay, the electric field lines will be from high potential to low potential. So what could be the value of X when compared to Y and Z? X has the maximum. So X has the maximum potential when compared to Y and Z. So the option is B. Okay, so A is your answer. So electric field, you have to remember the point, electric field will be from high potential to low potential. Okay. Next is electric potential due to a charge at its own locations. Okay, so electric potential due to a charge at its own location is not defined, and it's not defined. So when you substitute R is equal to 0, the electric potential formula V is equal to K Q by R. Okay, the electric potential due to a charge at its own location is not defined. Okay, then when you substitute R is equal to 0, you'll get V is equal to infinity. So if suppose a charge is here, what is the electric potential at its own location? Okay, so you'll get R is equal to 0. So when you substitute in this electric potential formula, you get V is equal to infinity. So the option is C is the answer. Since at its own location R is equal to 0, so we'll get V is equal to infinity. Next, the electric field at a point A is 500 volt per meter. So given electric field E is equal to 500 volt per meter from a point charge. The point A is at a distance of 6 meter. Okay, so the A point is at a distance of 6 meter. So distance is equal to 6 meter. So you have to find out what is the electric potential at point A. Okay, so we know the formula: electric field E is equal to V by D. E is equal to V divided by D. Okay, electric field at a point will be the ratio of potential divided by the distance between the points. So here V is equal to 500. So E is equal to 500 divided by 6. Sorry, E will be equal to not 500. E is equal to V. We have to find out, right? We have to find out what is the potential at this point. So we have to find out V. So V divided by D is 6. Okay, what is E? E is equal to 500 V by 6. Okay, so therefore V will be equal to 500 into 6. So we'll get 3000 volt. Okay, so this is the answer for electric field with respect to potential difference and the separation between the charge and a point. Okay, so we have the formula E is equal to V by D. So substitute the values. Just you have to find out the electric potential V. Now the potential difference between point and the point charges, right? The potential difference between a point charge Q and location A, okay, separated by some distance, okay, 6 meter. It is not depend on the path. Okay, whether it is dependent on the path, it is not dependent on the path. Even if you take a path like this and reach A, it doesn't depend on the path. The electric potential remains the same. Okay, so electric potential is a conservative in nature. Okay, doesn't depends on the path. Okay, not depends on path. So potential is a conservative nature, does not depend on path. Depend on path. Okay, so they asked whether the potential difference at A and point just depends on the path. No, doesn't depends on the path. So false. So it doesn't depends on the path. Okay, coming to the next one. If PQRS are set at equal distance as shown in the figure, the electrostatic potential at point O, then P, then R and S could satisfy the relationship. So when you look at this figure, we have charges at point O, R, P and X. So we have to find out which equation satisfies. Okay. with respect to the charges. So when you compare X and P, they are at equal distance. Given the question is they are at equal distance. All the points are at equal distance. So they are equal distance. Okay. So the potential at X, okay, equal distance from R and O. Okay. So potential of O minus VR. Similarly, the potential at P is also at equal distance from point O as well as point R. Okay, so from this Vs and Vp will have the same magnitude. From this we conclude that Vs will be equal to Vp, have same magnitude. Okay, so here V0 is V0 and Vr. Okay, so both are equal, V0 and Vr. We see the charge at O and R have same magnitude, have same magnitude. Okay, both have same magnitude. Okay, so when you find the potential difference due to these charges at O and R at point X and B, then Vs also will be equal to Vp. They have same magnitude. Okay, so obviously if you have same magnitude, when you take the difference of that, you will get the value as 0. So both are equal, same magnitude. So when you take the difference of same magnitude, we'll get answer as 0. So both from this we conclude Vs is equal to Vp. Now when compare to the charge at O and charge at R, okay, charge at O has 2q and charge at R has minus 2q. Okay, so when you compare the both the things, what you'll get? Charge at O, okay, charge at O is greater than charge at R. Magnitude of charge at O is greater than magnitude at charge P. Okay, so by concluding this, we have to find out the equations. So magnitude of A is charges at O is greater, right? So first we'll check out that option A is V0 is greater. Yes, V0 is greater than VR. Okay, it is correct. We given it. Charge of magnitude of charge at O is greater, right? Yes, it is greater. If the charge is greater, V is equal to KQ by R, right? So potential is directly proportional to charge. So if the charge is greater, then what about V0? V0 will be greater than VR. Okay, because from this we say that potential is directly proportional to Q. So when charge magnitude at O is greater, so V0 is greater than VR. V0 is greater than VR, okay. Next, Vp is greater than Vs. No, Vp and Vs have same potential. So it is not greater. So option A is ruled out. Option B is VR is greater. No. Only V0 is greater, right? Okay, so B is left ruled out and C is also ruled out because VR is greater than Q. It's ruled out. Option D is V0 is greater than VB. Yes. V0 is greater than VP. Yes, it is greater than VP. Both Vp and Vs are equal. Yes, they are equal. And it is greater than VR. Yes, VR is minus 2q. So potential from the highest magnitude of charge 2q. Okay, then we have a charge of 0 potential. Then we have a charge of minus 2q. This is the potential of O and this is the potential of Vs and Vp. And minus 2q is the potential of R. Okay, so this potential will be 2q V naught will be directly proportional. So this has the highest one. Okay, this is the highest potential. This will be the lowest potential. Okay. From this formula, V is equal to K Q by R, we say potential is directly proportional to the magnitude. Since magnitude at O is larger, we conclude that VO is greater when compared to R. Then VS and VP are in equal potential. So when coming to next one is 4 point charges minus Q, 2Q and 2Q are placed at the corners of the square of side A units. If the potential at the center of the square is 0, then Q will be equal to. Okay. So first, what is the formula for potential? V is equal to K Q by R. So from the center, they are saying that center potential is 0. Okay. So center potential is 0, that is V naught is equal to 0. Okay. So from the diagram we can write V naught potential at V naught will be equal to, with respect to A, use this formula K into, what is Q? With respect to A it is minus Q divided by R. So you have to find the half of the diagonal. What is the half of the diagonal, right? So what could be the distance for the half of the diagonal? So what could be the charge? Total charges, total side is A, and here it will be for the half will be A by 2. Similarly here also the total charges, total side is A and the half the side will be A by 2. Okay, then apply the Pythagoras theorem, we'll get OA is equal to root of A by 2 the whole square plus A by 2 the whole square. Okay, then we'll get OA is equal to A by root 2. So the distance from the center, okay, to all the diagonals of the square will be equal to A by root 2. Okay, so substitute this in this formula. So first we are finding out for V naught at the center with respect to A. So V naught at the center is equal to potential, okay, at A and O plus potential at B plus O plus potential at C plus O plus potential at D plus O. So we substitute K into minus Q divided by, what is the distance? Distance for all the diagonals from the center is A by root 2. So A divided by root 2. Okay. Next. Okay, next we'll write for the B it is K into, what is the charge? Minus Q divided by A by root 2. Next for C it is 2Q. So K into 2Q divided by A by root 2. Next for D it is 2Q. So K into 2Q divided by A by root 2. Okay. So if you take the common, K is common for, and A by root 2 is common. Okay, so we'll get minus Q plus 2Q plus 2Q. Okay, and what is the V naught value? V naught value is 0. So substitute V naught is equal to 0. It is given in the question, center potential is 0. So when this product gets cross multiplied, we'll get 0 is equal to, okay, minus Q and plus 2Q will get the answer as plus Q. and small minus q and plus 2q will get the answer as plus q. Okay, so we'll get q plus q is equal to 0, then q will be equal to minus q. Okay, so what is the option? Q is equal to minus q. This option is B. So just we are substituting the potential formula from the center to all the diagonal charges, substituting the value, and just you take the summation of all the multiple charges at the center, then we'll get the answer q is equal to minus q. Okay, next, the electric potential at a given point x, y, z is given by V is equal to 5x square plus 3y plus 15z. The electric field E at that point. Okay, so electric field E is equal to minus dV by dr. Okay, with respect to electric field will be the negative potential gradient. Okay, now Ex will be equal to minus dV by dx. Okay, so which will be equal to, when you differentiate 5x square with respect to dx, we'll get the answer to be, have the minus sign, answer will be equal to 5 2s are 10, to minus 10x. Okay, so after differentiating x, 5x square, we'll get minus 10x, then you differentiate y, ey, so ey will be equal to minus dv by dy, so which is equal to minus of differentiation of, what is y values? 3y, right, 3y with respect to dy, so you'll get the answer as minus 3. Okay, when you differentiate 3y, you'll get the answer as minus 3. Next we have to differentiate Ez. So when you differentiate Ez, from this equation we are taking x quantity, y, then Z. Ez is equal to minus d of dz, which is equal to minus d of 15z divided by dz, which is will be minus 15. Okay, so so the total electric field E will be equal to Ex I cap plus Ey j cap plus Ez k. Okay, so E vector will be equal to, so just substitute Ex values, minus 10 x I cap, then minus 3 j cap, minus 50 k cap. E vector is equal to, okay, so just differentiate each term, then we can find out the potential at that point. Okay, differentiate each term, then we can find out the electric field at that point. So option is minus 10 minus, so option is C. So to find the electric field at a point, electric field will be negative of potential gradient. Next, dipole moment is, so dipole is there, K plus Q minus Q, dipole is there. The dipole moment is given by P is equal to 4 into 10 to the power of minus 9 centimeter. Okay, it's separated by a distance of 3 meter. Okay, so L is equal to, small short distance is equal to 3 meter. Okay, so given, note down the given things. So we have the P value, P is equal to 4 into 10 to the power of minus 9 centimeter, which is equal to 4 into 10 to the power of minus 9 into 10 to the power of minus 2 meter. Okay, and L is equal to 3 meter. Okay. So now just substitute for the potential of a dipole. So potential of a dipole is given by the formula, okay, V is equal to Kp cos theta by r square is the formula for electric potential of a dipole. Okay. Now they asked to find the axial line. What is the potential at the axial line? So axial line, this is your axis. So some point here. Okay, let it be P. Okay, or let it be A. Some point A. What is the potential? What is the potential at this point A? Okay, so substitute all the values. So we'll get V is equal to K, we know 9 into 10 to the power of 9 into P value is 4 into 10 to the power of minus 11. Okay, and cos theta. So what is theta? Theta is 0 degree. Okay, so cos 0 divided by r square. What is r? R's the distance is 3 the whole square. Okay, what is cos 0? We know that cos 0 is 1. So 9 into 10 to the power of 9 into 4 into 10 to the power of minus 11. Okay, into 1 divided by 9. So 9 gets cancelled. So 4 into what you have? Plus 9 minus 11 by. So we'll get 10 to the power of, okay, minus 2. Okay, so 9 into 10 to the power of 9, then 4 into 10 to the power of minus 11, cos 0 is 1 divided by 9, 9 gets cancelled, so 4 into 10 to the power of minus 2 volt will be your answer. Then at equatorial point, they have asked to find the potential at equatorial point is perpendicular point. Okay, let it be S. This is our equatorial point. Okay, equatorial point, theta is equal to 90 degree. Okay, so we know that cos 90 is equal to 0. So when you substitute in this formula, V is equal to Kp cos 90 is 0. So when you substitute cos 90 is 0, then you'll get V is equal to 0. Okay, substitute in the formula. Okay, so I hope you have understood. Okay, thank you. Kindly subscribe, like and share to your friends.